Now that you know how to classify compounds as acids, bases, salt, and covalent compounds, we're going to learn how to name them. We're going to start with the covalent compounds because they're quite separate from all of the others. The rest of them will be very similar to each other, but covalent compounds have their own special naming practice. So we'll start with that. But before we start doing some naming, I'd like to talk to you about DHMO. It is known as a deadly toxin, and yet we are finding it everywhere. Normally, I don't spend a lot of time on politics, but I feel very, very strongly about this particular issue. I think this issue is one of the most important issues we can stand for in this political cycle. Please feel free to share this information with anybody and everybody. It's very, very important. I'd like you to take a few moments to read through this, so stop the video as you need to. I'm going to expand each of these sections briefly so that you can see them, but stop the video as you need to and then continue it once you're done reading that section. Sorry, this one did not copy well. And here we can see many of the dangers caused by DHMO. This ban was recently brought into a local city to see if they could get rid of DHMO. What do you think? Do you think we should get rid of it? We'll talk about it again at the end of this section. Let's talk about the process of naming binary covalent compounds. When we write these names, we're going to remember that there are only two elements. That's why we call it a binary covalent compound. And we know it's covalent because it starts with a nonmetal and it ends with a nonmetal. So we're looking at two nonmetals. The way that we write the names is we start by writing the names of each of the elements in the compound. We start with that as simply. So then, on the first name, we're going to keep that name the same, but on the second one, we're going to change it to an IDE ending. So we'll talk about those as we continue on. Then, after we've written the base name of the compound, what we're going to do is write in the number that indicates how many of that atom is present. So we're going to be using Greek prefixes, and you will need to memorize this list. So mono means 1, di means 2, tri means 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. A couple of them are a little bit confusing, some people have trouble with. First off, remember di means 2. That one's one of the ones that people have trouble with. They like to use a different abbreviation I'm not going to mention. Penta is, think about like the pentagon. Tetra, it means 4. The other ones that are a little bit challenging are hexa and hepta. A lot of people like to mix those two up. Octanona and deca most people get. They seem to make sense. But hexa and hepta are easily confused. The way that I remember which one's which is that hexa has an X in it, and so does the number 6. So if you can remember the one with the X is 6, you should be in good shape. So memorize those, work on them. It'll only take a moment to memorize them. We're going to use them a lot now, and we're also going to use them in Unit 4 in a completely different way. This is a list of the nonmetals we'll be using for the covalent compounds. The first name is listed if it's the first element, is how you'll use it. But the second name is what you'll use if it is the second element listed in the formula. So our hydrogen becomes a hydride, carbon becomes carbide, nitrogen becomes nitride, oxygen becomes oxide, fluorine becomes fluoride, phosphorus becomes phosphide, sulfur becomes sulfide, chlorine becomes chloride, bromine becomes bromide, and iodine becomes iodide. There are others, but these are the ones that we'll be using in this course. So let's practice some. In this case, we're going to have P2I4. We're going to see that the first element is phosphorus, so we're going to write phosphorus. The second element is iodine. It becomes iodide. Then in front of that, we're going to write how many of each of them there are. So there are 2 phosphorus, so we're going to put in diphosphorus. And then in front of the iodide, we're going to say that there's 4, and we're going to use the prefix tetra. So the word is diphosphorus tetraiodide. For the next one, we're going to have sulfur as our first element. Nitrogen will become nitride. We're going to say how many sulfurs there are. There are 3, so we're going to say trisulfur. And then nitride, there's 6, so we're going to put a hexa in front of the nitride. So it's trisulfur hexanitride. I'm going to have you pause the video and try the rest of them. Okay, so we're back. For this one we have O5Cl8. We see the oxygen first. We're going to write oxygen. The second element is chlorine. It becomes chloride. There are 5 oxygens. It becomes pentaoxygen. There are 8 chlorines, so we're going to put octachloride. So it's pentaoxygen octachloride. The next one, Br3H7. First element is bromine, so we write bromine. The second element is hydrogen. It becomes hydride. We put the number 3 in Greek is tri, so it's tribromine. And then 7 is hepta, so it becomes heptahydride. So tribromine heptahydride. And our next one, we have N4P10. N is nitrogen, P is phosphorus, but it becomes phosphide because it's the second one. 4 is tetra, and 10 is deca, so we end up with tetranitrogen decaphosphide. And our last one, we have F5I9. Fluorine is written as fluorine. Iodine becomes iodide. 5 is penta, so we have pentafluorine. 9 is nona, so nona iodide. So pentafluorine nona iodide. How did you do? There are a few exceptions to the rules of naming covalent compounds. The very first one is that we have the word mono. Now mono on the first element does not get mentioned, but if it's on the second element, it must be mentioned. So we'll see in this example, we have bromine with F5, it becomes bromine pentafluoride. We don't say the mono or the bromine. Or in the second one, we have sulfur dioxide. Now the third one has an extra issue, so we can have carbon and then we put monoxide. But when you read that, it looks like monoxide, which is totally wrong. So we're going to actually call it carbon monoxide, which you've probably heard of. And this is a good one to remind you that we don't put the mono in front of the first one, but we do put it in front of the second one. So carbon monoxide. And the second thing it reminds us of is we have to be careful of how the thing sounds. So when we put 2 O's together, it makes the oo sound. We're only going to write one of the 2 O's. So it's important to know when you do and don't do that. On the next one, we have fluorine. Again, no mono in front of it because it's only one and it's the first one. But the second one needs the mono. And then it follows up with iodide. I know it looks like an L like Florida, but this is fluorine monoiodide. And in this case, I do put the O in because it doesn't make the oo sound. It makes an O-I-O. You see each part. Monoiodide. Okay? And there are 2 more exceptions I'd like to mention. Now, the only reason I'm mentioning these 2 is because they really do have common names. So I want you to know the common names for these 2. I don't normally ask that, but for these 2 it's special. So the first one, NH3, its official name is nitrogen trihydride, but its common name is ammonia. Notice that that is not ammonium, but ammonia. We're going to see that later on in Unit 3, why we make that distinction. But this is ammonia, not ammonium. Ammonium has a positive charge with 4 hydrogens, not just the 3. The second one has the common name water. Can you tell me what its official name would be? Pause the video while you write it out. So yes, we have 2 hydrogens, that's dihydrogen. Then we have 1 oxygen, that's monoxide. Remember, no double O's. So dihydrogen monoxide. So writing the formulas for the covalent compounds is even easier. All you're going to do is read out what the first element is, then write out how many of them there are, using the Greek prefix and translating it into a number. And then for the second one, we're going to change that element from its "ide" ending, but we know what the element should be, so we're going to write the right symbol for it, and then write in how many there are from its Greek symbol. So let's give this a try. So the first one says disulfur heptaoxide, so we're going to put sulfur, we're going to put S for sulfur, Then we're going to put a 2 for the di part. Then we're going to put O for oxygen, which was oxide. And we're going to put, for 7, we're going to put 7 for hepta. So we get S2O7. Why don't you try the next one? Let's go ahead and pause the video for a moment. And you should see carbon tetrafluoride becomes C. No number on this. We don't write the number 1. And then F with a 4, because tetra stands for 4. The next one, dinitrogen pentasulfide. We have N for nitrogen, 2 for di, S for sulfur, 5 for penta, which gives us N2S5. And our last one, dinitrogen monoxide. We're going to have N for nitrogen, 2 for the di, O for oxygen or oxide, and 1 for the mono. We don't write the 1 in, so it's N2O. Let's go back to our discussion about DHMO. All of these things that you see on this page are true about DHMO. After knowing how to name things, what is that formula? So DHMO stands for dihydrogen monoxide. You got it. It's just water. So why would we want to ban water? Well, because of all of these things that are on here, they are true facts. They just aren't very accurate. This petition was brought to a city council. It was somewhere in like Laguna Woods, I believe, somewhere in that region. It was brought to a city council. They voted on it, and they did vote to ban it. And then the person who brought the petition up said, no, this is a joke. Just know that you should not be banning everything in the world. So while all of the facts on this page are true, it is a very dangerous chemical. People drown in it. It does help with electrocutions. It is found in acid rain. It's the rain part. It's found in all of our lakes and rivers. It has many, many problems. It also has many uses, and we can't live without it. So my big message here, and as I said, I feel strongly about this politically. I do feel strongly, and that is to warn you that whatever you read it with a grain of salt, which means you should always make sure that you read carefully and know what you're voting for and what you're voting to ban. It may have some actual good uses, and you may be very sad to have gotten rid of such an important chemical. Anyway, that's my little bit of political plug. Make sure you know what you're voting for before you vote.